G'day folks, I'm just troubleshooting this Panasonic 42-inch plasma TV. It's the last of the lot that I got off Jay the Aussie. Looks like it's in pretty good condition. What model is it? It's a TH42 PS9WK. And well, when I turn it on, initially it started making a high frequency buzzing noise, and now it's more of a low frequency buzzing noise, like someone tapping on a piece of glass. And that kind of made me think, why would somebody be tapping on a piece of broken glass? Well, it's something I overlooked initially because I couldn't see any major fractures in the panel. Like, it looks pretty good at first. But if I go down here, oh dear, there's a hairline crack about 1 inch long. And another one a little bit further along that's only 1/4 of an inch long. And it's right near a screw mounting point. So I'm guessing this is probably transport damage or something like that. It's just been mishandled and busted, because everything works. If I turn it on, green light comes on, you get horrible buzzing noise, but all the voltages are perfect. Everything's perfect. The power supply is working perfectly. The control boards are working perfectly. X and Y sustain are fine. It's all good. Just the actual display panel itself is screwed. It's physically broken. And you don't see anything, you don't get any flashes on the front of it. No vacuum, no operation. So yeah, if you find a TV like this that's making a weird noise like that, you probably have a very fine crack around the outer edge of it. Yeah, if it's not obvious. I mean, you can't really see it from here without a flashlight. So take a flashlight and just go around the outer edge of it, and sure enough, you'll probably find it. And that's not on the front glass either, that's on the backing glass. There's 2 layers. There's a back layer which has, is it? It might be the front glass actually, because you can see it. But yeah, there's 2 layers, and either layer can crack, even in the tiniest of places. It's not safety glass, it won't just suddenly craze and explode. You'll just get a fine fracture around the outside, and that's the end of it. But yeah, everything else is working. Digital board's interesting because it takes slot-in cartridges. It's got one for PC input, one for basic AV input, SVHS, and that's it. So, evidently a broadcast monitor, and a very screwed one, so I'm going to pull all the bits I can off it, including these buffer boards or whatever they are, these little things on the side, and I'll just keep them as spare parts. And be wary of those capacitors too. If you just pull the plug and go to work on it, you can get a dangerous zap from those. Each one's 1700 microfarads, 200 volts DC. So short them out, discharge them whichever way you want, using a resistor or a water resistor or something like that. Just discharge them and be safe. Well, I'll strip this one down. I'll pull the panel out complete and keep it aside for another microwave transformer experiment. I don't expect it to do anything because there's no vacuum, no inert gas, but then we might be able to introduce some very large capacitors to it, and yeah, maybe even blow it to pieces. Because for those who don't know, a plasma TV panel is essentially a cold fluorescent tube, except instead of having a couple of filaments in one single coloured display, it's actually each pixel block of red, green, blue is 3 cold cathode lamps. They don't share an independent vacuum, they share the common vacuum and dielectric layer of the 2 layers of glass on the panel, and the dielectric in this case is just a rare gas like neon or something like that. I can't quite remember what they are, but it's an inert gas, and they operate as independent cold cathode lamps. running at variable brightnesses, and all of these boards and controls are responsible for switching on those lamps in such a sequence that it creates a picture. LCD is the other way, where you have a big backlight, cold fluorescent lamp backlight, and the pixels work by basically opening and closing like shutters. You got red, green, blue, and they're controlled by, say, a thin film transistor display or TFT display. They have a tiny little transistor in the corner which is way smaller than you could ever see with the naked eye, and that transistor is responsible for opening and closing them to a varied degree, letting that wavelength of light through. They're quite interesting when you work out how they work. So yeah, enough rambling on about this rather screwed plasma. I'm quite happy that I've got a lot of parts that still work. I believe they work well enough to put them in another TV and see if it works. I wouldn't put it in a TV if I knew it was short or dying. Like if this board was short, it'd be pulling the power supply down. In this case it's not, so it's safe enough to put in another set. But if it was pulling the power supply down and forcing the power supply to restart, or try and restart, then I wouldn't put it in another set, just for the simple fact that it could damage a good power supply. That's one risk you take if you swap boards like these, which may have a short circuit in them. You could blow something which you don't really want to blow. If, say, your problem's on the digital board and you do something silly like swap a shorted board from one of these to a good one, you could blow your power supply as well and write the set off. So yeah, just a little bit of information that I've learnt recently. Not the hard way, just doing research, just looking at papers and things like that. I still don't know an awful lot about plasma TVs, but I know a lot now that I've had so many to mess around with. I mean, still have to look at the Philips. That's an LCD. That'll more than likely end up fixed. I'll be quite happy to fix that. It's a nice 40-inch LCD with DVI input. Thanks to the bazillion commenters who told me that I can get a DVI to what was it? It was DVI to HDMI converter, or this plug adapter. Absolutely brilliant. I like that idea. I didn't know that the coding signals were the same, and that's why I didn't think you could do it, was because the DVI might have been a different signal, but it's not. So that's good. Yeah, I think this video is big enough, and thanks for watching. That's how old it is. It's only 2007.